at the moment. Okay, we'll start a new topic today. Uh, First, the mass of an object. How we define mass? It is amount of matter. So how much matter is there or how many particles are there? So amount of matter or amount of particle inside an object, that is known as the mass of an object. So example, you have an object. So the total number of the particle or the amount of matter which is present in it, we call that as a mass. And the SI unit, this is the first chapter, making measurement. This is chapter 1, but I'm for a physics, I will go according to the syllabus sequence rather than the book sequence. So I will follow the sequence of the syllabus. But mainly you can find this thing in chapter 1, making measurement, if you are following the book of IGCSE Physics by David Sang. Otherwise, if you are following another book, you can send me the index picture and I can let you know which chapter or which topic I'm discussing. If your school is following a different book, you can just send me the picture of your index, book index, and I can discuss and I can mention which topic I'm discussing. So amount of matter or amount of particle inside an object, that is called the mass. The SI unit of mass is kilogram, kg, and the other units can be gram or it can be tons. But the standard, the SI or System International Unit of Mass is kg or kilogram. Mass of an object, what do you think? It's a scalar or vector?
Scalar quantity.
Yeah, so mass of an object is a scalar quantity. Why we call it scalar? Because it does not have a direction. It has magnitude. Like if you are saying my mass is 60 kilogram. Normally we used to say my weight is 60 kilogram, but scientifically it's wrong because weight is not in kilogram. Weight is a force which is in Newton. Scientifically, when you're saying to someone like my weight is say 70 or 60 kilogram or 50 kilogram, that's scientifically it's wrong. So 60 is the magnitude where kilogram is a unit. So it has a magnitude and it has unit, but it does not have a direction. You don't specify that my mass is 60 kilogram in east, west, north, south, upward, downward, right, left. So these directions are not included. That's why we call that as a scalar quantity. Mass of an object remain constant if the number of the particle remain same. So if the number of the particle does not change, the mass of an object won't change. Example, you're on Earth and you travel to moon. Example, your mass was 60 kilogram on Earth. So if you travel to moon, if your number of the particle remains same, then your mass will also be 60 kilogram on moon. So mass of an object does not change from place to place, it remains constant. But another example, if you say you have a hot water in a container, so this container is filled with a hot water, and some of the water molecules escape, evaporate. The mass will change, yes or no? Is there a change in mass in this example? A hot water is there in a container and it's having an opening that it is open from the top. You left it in a room for some time. Is there a change in mass in this example? Yes or no?
Yes.
Yes, there is a change in mass. Why there is a change in mass? Because the particles, the number of the particle will change. Because a hot water is there, in a hot water, evaporation will take place. So when evaporation will take place, if a molecule escapes, so the number of the particles which are left behind, so the total mass will decrease. So due to evaporation, the number of the particle decrease. That's why the total mass at the end will decrease. So mass of an object is remain constant if the number of the particle remains same. If the number, like for example, you are doing an exercise. When you're doing an exercise, continuously, if you're doing an exercise for a week or 15 days, your mass will reduce. Why your mass will reduce? Because you're losing the particle or you're losing the matter, and matter is converting into energy. So if the number of the particle or matter changes or reduce to energy or change to energy, then the mass will change. Otherwise, if the number of the particles are same, the mass will not change. Is it clear? If anyone want to take a screenshot, can take now. I'll move on to next part. You don't have to copy during the class, during a session. At the last, you can copy, like I will share the recording with you, so you can copy from that. Because main focus is to make you understand the things and do more numericals, more questions within the class. Otherwise, if you copy all this thing in the class, will not have enough time to do examples. Next is weight of an object. Definition of a weight. It is gravitational force experienced by the object. So the gravitational force experienced by the object is refers to weight of an object. And different planets have different force of gravity. Like example, when we are talking about Earth, the size of the planet, the mass of the planet will decide its gravity. Example, the Jupiter in our solar system is having the highest gravity because it's having greater amount of matter. Then you have Earth and then Moon. The gravitational force of the Jupiter, the force of gravity of the Jupiter, you have to learn these values. The force by which a Jupiter is pulling the object towards the center, that's called force of gravity. And for every 1 kilogram, it applied 25 Newton force. For every 1 kilogram, it applied 25 Newton force. Whereas Earth, the gravitational force of the Earth is 10 Newton per kilogram. Means every kilogram, for each kilogram, the force of 10 Newton act. And for Moon, the smallest value of a gravity here, it is about 1.66 Newton per kilogram. These are the forces of the gravity which 1 kilogram experience on Jupiter. It will experience 25. On Earth, object will experience 10. And on Moon, the object will experience 1.66. So example, there's an object An object is there, identical objects. One is on the Jupiter, the same object on Earth, and same object on the Moon. The mass of this object is 50 kilogram. The mass of this object is also 50 kilogram on Jupiter, and mass is 50 kilogram on Moon. So identical object with the same mass. But what happened? What is the definition of a weight? Weight is the gravitational force experienced by the object. So what is the gravitational force experienced by this object? How you can find that? Look, for every kilogram, for each kilogram, it experiences a force of 25. So 50 kilogram, how much force it will experience? It will be 50 multiplied by 25.
25.
So what's the answer? 50 multiplied by 25?
1,000 to 1,250.
1,250. What will be the unit? Because it's a force, so the unit is Newton. So this object will experience a force of 1,250 Newton. The same object is on Earth. The force by which Earth apply on this object is 10 Newton per kilogram. If 1 kilogram is there, Earth apply a force of 10 Newton. So what will be the weight of this object? So it will be 50 multiplied by 10, because each kilogram experience 10 Newton. So 50 kilogram, it will be 50 multiplied by 10, which is equals to 500 Newtons. Same way on Moon, the mass of an object is 50 multiplied by force by which it is attracting the object, that is 1.66. So 50 multiplied. Okay. Look what happened. Each planet is having its own gravitational field strength. This is called a gravitational field strength or strength of a field. On Jupiter, the value of a gravitational field strength is 25 Newton per kilogram. If there is 1 kilogram, that 1 kilogram will experience a force of 25. If an object is on Earth, each kilogram experience a force of 10 Newton. If object is on Moon, each kilogram experience a force of 1.66 Newton. Now you have 3 identical objects and all have the mass 50 kilogram. So the question is, what is the weight? Weight means the force the object will experience due to it is a gravitational force experienced by the object. So every kilogram or each kilogram experience 25 Newton. But there's 50 kilogram. So that's why it is 50 multiplied by 25. So which make 1,250 Newton. Same thing, the object mass is 50 and each kilogram experience a force of 10. So 50 multiplied by 10. So the total force experience will be 500. And on Moon, it will be 50 is the mass multiplied by each kilogram experience a force of 1.66. So 50 multiplied by 1.66. What is the answer?
83.
83 Newton. Why I did not write kilogram? Because weight is a force and the unit of the force is Newton. And why it is not kilogram? Look, you can understand from the unit. Mass was 50 here, so 50 kg multiplied by 25 Newton per kilogram. So this kilogram will cancel with kilogram. So what you are left with? You are left with newtons. And weight, the unit of the weight is, the SI unit is Newton, denoted by capital N. So unit of mass is kilogram, whereas unit of weight is Newton. Weight is actually a force of a gravity which object experience, and it changes from place to place, even from planets to planet. Even it changes when you're, like example, an object is on Earth. When the object is on Earth, the object will have a greater, because the strength of a gravity is more on the at the surface. But as an object move away from, like you have a satellite, Say a satellite is there which is revolving around. So if this satellite is revolving around the Earth, what will happen? Because the value of the gravity of Earth is weaker as we move away from the surface, so the weight will decrease. So how to know, how to calculate the weight? The formula which we use to calculate the weight is equals to mass of an object multiplied by gravity, where m is a mass and g refers to the gravitational field strength. So G can be refers to or as known as the gravitational field strength, and m is a mass of an object. So you can see here the weight of an object is not constant. Weight of an object changes from place to place, or it vary from one place to another. Whereas mass of an object remain constant, the number of the particle is same, so the mass will remain same. What do you think? Weight is a scalar quantity or it's a vector quantity?
Vector.
The weight of an object is a vector quantity because it is having a direction. So whenever you mention weight, it is a vector quantity. But what is the direction of the weight? Like if I say it's a vector quantity, to be a vector, it should have a direction. What is the direction of the weight?
Towards the center of the earth.
Towards the center, or because you can also mention it's downward. In these all examples, when you compare the frame of your reference, because even a person is, an object is here, so it is acting towards the center. If object is here, so it depends on the frame of the reference, how you're considering an object. A vector quantity is having a quantity which is represented by a direction is called a vector. If a quantity is not represented by any specific direction, we call that as a scalar. So why weight is having a direction? So weight is a vector quantity. Why? Because it is having a direction. It is always acting towards the center. So if I show an object is there, and revolving, say a satellite is revolving around this planet. What is the direction of the weight? A, B, C, D.
D.
Yeah, just a minute. Take a screenshot. If anyone want to take a screenshot, can take now. So I'll move on. Example of a scalar quantity such as time. Like example, if you mention a time, you don't specify a direction. You just say 2 minutes pass, 2 hours pass, 1 minute pass, 1 second, but you don't specify direction north, south, east, or west. So you call that quantity without a direction as a scalar. With direction is refers to vector. So what is the direction of the weight in this example? A, B, C, or D?
D.
Uh,
D.
So the direction of the weight is acting towards the center. So that's why D is the right answer. Same thing, if I say an object is on the ground, an object is on the floor, and what is the answer? What is the direction for the weight?
B.
B.
Yeah, what is the direction of the weight? A, B, C, or D?
B.
Mention your answer in a chat for this. Okay, for this one, B is the right answer. Weight is acting downward because actually this is on the surface, so it depends on according to a question you have to identify the direction of the weight. But the idea is that weight is always directed towards the center because this object is on the surface. So when I draw like the whole, so the direction towards the center is B. That's why B was a right answer. So when we compare the differences between mass and weight, if we summarize this, yeah, take the screenshot. So mass and weight, the difference, number one, it is amount of matter, where weight is a force of gravity. Mass of an object, SI unit is kilogram. Weight of an object, the SI unit is Newton, denoted by capital N. Mass of an object remains same if the number of particles are same. Weight of an object vary or changes from place to place. Mass of an object is measured by the instrument which we use. It's called a beam balance. Where weight of an object is measured by spring balance. So spring balance is mainly used to measure the spring balance, or force meter you can also say. So spring balance or force meter is used to measure the weight of an object, and mass of an object is measured by beam balance. I will show the picture for you. And the last one, mass of an object is a scalar quantity, where weight of an object is a vector quantity. The formula which relate both mass and weight together, that formula weight is equals to mass multiplied by gravity. So this is a formula which relate mass and weight, where W is the weight of an object, M is the mass, and G is the gravitational field strength or the strength of the gravity. So you can learn from this triangle. So you can learn from this triangle, like example, if you need weight of an object. So if I need weight of this object, then it will be mass multiplied by gravity. If I need mass of an object, it will be weight divided by gravity. And if I need value of the gravity, it is weight divided by mass. Is it clear? Any doubt in this? You can take a screenshot for this. So here you can see the balance. This is a beam. This is called a triple beam balance. This is normal beam balance, and this is a digital balance or electronic balance. And the spring balance, the force meter or a spring balance. So if you want to measure the weight of an object, we can use this spring balance. And if you want to measure the mass of an object, we will use either we can use a triple beam balance or digital or electronic balance directly placed, and you will get the mass. Or we can use a simple beam balance. Then when the level is, if both masses are same, then the levels will be horizontal. Like both levels will be same as well, and it will be horizontal exactly. Solve this question. The mass of an object on Earth is 25. Calculate the weight of object. The gravity of Earth is 10.
Send it to the group, sir.
No, just solve it because it's a very short question. You just can mention in the chat now. Yeah. And what about example question 2? On Earth, the gravitational field strength is 10. On Moon, it is 1.6. If an object has a weight of 50 Newton on Earth, what is the weight on Moon? So weight on Earth is 50. You need a weight on Moon. That's a question. if weight on Earth is 50, what is the weight on Moon? How the weight on Moon is more than weight on Earth? (1.6 multiplied by 5). Yeah, so what is 1.6 multiplied by 5? Look, how you will solve this question? First, you will find the mass. How to find the mass of this? The weight is 50 and the gravity is 10. So first I'll find the mass. Because mass on Earth and mass on Moon is same. So weight is mass multiplied by gravity. So weight is equals to 50. Mass we don't know and the gravity is 10. So gravity is multiplied, other side it will be divided. So 50 divided by 10, which is equals to 5 Newton, or 5 kilograms, sorry. So mass is 5 kilogram. After knowing the mass, again use the same formula. Weight is equals to mass multiplied by gravity. So mass is 5 multiplied by, what is the gravity? The gravity is 1.6. So 5 multiplied by 1.6, which is equals to 8 Newton. And obviously, it should be obvious that the weight of an object, because gravitational field strength of the Moon is much weaker as compared to gravitational field strength of the Earth. So that's why when you compare the weight on Earth should be more and weight on the Moon should be less. So first we get the mass, and mass multiplied by gravity will get the weight on the Moon. Is it clear? Yes.
Sir, like as the moon has a weaker gravitational field strength, I
Yes.
will be able to lift something more easily on the moon, right?
Yeah, that's right. Because it's lighter as a smaller weight, so it will be easy to lift any object on the surface of the Moon as compared to that on Earth.
Yes, sir. Thank you.
Then we define a term which we call inertia. Inertia means it's a property of a material to resist change in state. When the object resists the change in state, we call that property as inertia. Example, a truck is there and the truck is moving. Say the truck is moving with 60 kilometer per hour, with a speed of 60 kilometer per hour. And you want to stop this truck. So you stand in front of the truck and you try to stop. Can you stop this truck when it is moving?
No.
You cannot stop this truck. So means the truck is having some property which is not allowing you to stop the truck, or truck is having, yes Salah? Yes Salah, any question? Okay. So basically truck is having a tendency to resist the change in state because it's a moving object. So if it's a moving object and you're trying to stop the truck by standing in front of that, but you're not able to stop the truck because truck is having a property, and what we call that property as inertia. So property of a material to resist the change in state. Same thing, there's another truck, same size truck, and that truck is stationary. It's not moving. So another truck is there which is not moving or stationary or rest. Can you move this truck by pushing it?
No.
So you cannot move it, like it's difficult to move this object. So when it is difficult to move this object, tendency of the material, like the truck is, you're not able to move the truck, or truck is resisting the change in state. When an object resists the change in state, if it's a moving object does not try to stop. And same thing, if it's a stationary object, it does not try to move. So what we call this property as inertia. And inertia is directly proportional to mass of an object. Means greater the mass, greater the inertia. So if you have a truck and you have a car, both are stationary, both are at rest. A car is not moving as well as the truck is not moving. Which one is easy to move, truck or a car?
A car.
A car is easy to move. So in this, a car is easy to move. Why? Because a car is having less mass. So if something having a less mass, means it is having less inertia. Same thing, if in this example truck is having a greater mass, so if object is having a greater mass, means it is having a greater inertia. So the term inertia means property of an object to resist the change in state. You can also understand in a simple example. Say your two friends are sitting on the chair. One is having a mass of 30 kilograms, another is having a mass of 60 kilograms, and both are sitting on the chair. Which one you can move it easily?
6 kilogram.
60 kilogram or 30 kilogram?
30 is
30
correct.
kilogram.
30 kilogram. So means 30 kilogram is not resisting the change in state. 60 kilogram is resisting the change in state more. So means 30 kilogram is having lower inertia or smaller inertia, and 60 kilogram is having a higher inertia. Is it clear, the concept of inertia? So the property of a material to resist the change in state, if the material does not change its state or try to oppose the change in state, we call that property as inertia.